So welcome again to today's featured webcast, Break the Barriers to Big Data Insights with Cloudera, Tableau, and SyncSort. Our speakers today will be Matt Brandwein, the Director of Product Marketing for Cloudera, Paul Lilford, Global Director of Technology Partners from Tableau Software, and Steve Topman, Director of Strategy for SyncSort. And with that, I'd like to turn over the webinar to Steve Topman, our first speaker.
Thanks, Arlene, and hi, everyone. So why are we here today? Three leaders together. You've got SyncSort, Cloudera, and Tableau driving big data insight. Each has a specific role, but together we allow you to access data and deliver insights in a way that was never considered possible before. As a rough agenda, we're going to talk about the data warehouse vision and reality. We're going to look at legacy data and an enterprise data hub. We're looking at offloading that information and workloads to Hadoop from legacy sources like the mainframe, and transforming all types of data into self-service analytics. There will then be a live demonstration, so you get to see all these products working. We'll do a quick customer case study, and then some time for Q&A. So all through the webinar, we'll have a series of these polls. So this is the first one. So if you could pick all of the ones that apply to you, please. I'm going to leave it open for another 10 seconds, so please put your response in. Okay, so it's interesting. We thought only small data would be a bit funny to add in, but it seems that the vast majority of people don't yet have big data, but they assume their data volumes grow. So that's consistent with what we're seeing out there in the industry. So what is this? If you're sat there thinking it's a 3.5-inch floppy disk and it stores 1.44 meg of data, chances are you were born after 1998. In 1998, the iMac was launched, and it was actually the first home computer not to have one of these as standard, just a CD drive, which was revolutionary at the time. Now, the funny thing is, to anyone born after 1998, this is the save button in most applications, and yet they have no idea why it's called the save, why it is the save button, and they certainly wouldn't call it a floppy. So over Christmas, I'm sat with my mum and my 4-year-old nephew, and there's a bit of a kerfuffle going on. And basically, I lean over and I realize that they're playing with Ollie's iPad, and my mum is trying to figure out how to get a Christmas pudding recipe, very British thing, onto her iPad. So obviously, I get dragged into it, and I very quickly realize it's not that easy to get data from a 3.5-inch floppy disk onto an iPad. Now, the funny thing is, I guess the equivalent today of a floppy disk is a USB drive. So a lot faster, they can store a lot more data. But actually, to get that data from that floppy disk onto the iPad, I ended up using Dropbox or Box. And it's really amazing. There's a technology change that has happened there. And it's happened right in front of my eyes. And disruptive technology advances make you completely question what has been the norm, what has been best practices. And that's exactly what we're seeing with the data warehouse and the path to data insight. So back when I started my career in data warehousing in the 90s, straight out of university, this is what the business was being promised. We were going to bring together all these different data sources. We were going to combine them into a data warehouse so that suddenly you would have a single trusted source of information across the organization. It doesn't matter whether you believe in Kimball or Inman, top-down, bottom-up. This was kind of the vision. And the idea was that instead of using hand-coded SQL and COBOL, you'd use an ETL tool. And that ETL tool would rip the data out of those sources, move it to the warehouse, move it to the marts, and then you'd deliver them to reporting tools. And the reason you'd use an ETL tool instead of hand-code is because it would give you a graphical interface that even a graduate that just joined your company could use. It wouldn't require rocket scientists. It would give you scalability to handle data growth. Remember, back then, a big warehouse was a terabyte. It would give you metadata-driven architecture, so you'd have reuse and governance and the ability to share things in a team. It would have these low-level connectors to all the data sources you could want, including the mainframe, and then it would deliver all that data out to the end users. And warehouses were incredibly successful. Consulting firms at the time used to joke about how giving information to the business was like the drug dealer sales model. You'd give the business users a little taste with a small data mart and some reports, and they would get hooked. And that would justify a multi-year, multi-million-dollar warehouse project so they could get those same reports every day. And then, of course, you have the reality today. Just like a teenager hitting adolescence and growing pains, warehouses have been hitting the same issue. You end up with this spaghetti-like architecture. If you go to any customer and ask them, draw your architecture on a whiteboard, it starts to look like this very quickly. So what happened was the ETL tools, the market-leading tools, just couldn't cope with the volume of data. They couldn't handle basic functions like sort, join, aggregation, merge, filter, which are core to ETL. So people started moving that processing to wherever it could be done. That ended up being in the databases. So this whole notion of ELT appeared. Push the processing into the database with its optimizer so it can handle it. So staging, this dirty little secret over every warehouse, started to slip into the core relational database. And the processing got moved wherever it could be done. That ELT became impossible to maintain. Customers describe it as being like an onion, where you don't want to change the SQL below, so you add another layer on top and another layer on top. And they call it like an onion because if you ever had to change one of those, even a top layer, everyone ended up crying. So today, Gartner says the average cost of an integration project is between $250K and $1 million. But it's really the end users that feel the pain of this. So inside that mess, if you want to add a new column, it can take weeks or months. You don't get a complete history because there's so much dormant data in the warehouse that is being constantly loaded, but no one's using. And then on the reporting side, there's just, frustration. I mean, Paul, do you want to add anything?
Yeah. So Steve's point here, folks, is the challenge of the warehouse quickly and the scale of it quickly left the business user behind, and so all of the time was spent just processing to get information in and trying to take transactional data and turn it into an analytical store and make it usable for people. But the technology made it so complicated, the volumes got so large that the relevance of this to the business user started to drift, and the speed and agility that business people needed to make decisions to move the company ahead started to get left behind. And when you see an architecture like this with all these arrows and all these things flowing around, what it typically means is the complexity and technical nature of it, is at the forefront. And the most important thing is actually how do we drive our business forward? How do we make a better informed decision? How do we discover the right trends in our data to make this world-class and to give us a competitive advantage in whatever industry or field we're in?
And that's exactly the point. There's this massive gap between the vision and the reality. And it's important to know that business users are getting great information from warehouses, but they still want all the things they were promised in the first place. They're looking for fresher data, longer history, faster analytics, and yet they're suffering from batch windows that are running longer and longer. Many customers have to keep their analysts waiting in the morning until the warehouse is finished loading. I know one customer that rings a bell to let them know that tea break and coffee break is over. Now they can do the analysis. And they're getting a smaller and smaller subset of the data they want in the warehouse because there's so much other stuff happening there. Queries get slower, and those column changes take weeks. And in my experience, it takes weeks once they get to them. There's often a 6-month backlog before they even start. And the funny thing about all of this is every year the CIO has to go to the CFO and say, hey, I need another few $1 million for the warehouse. And the CFO goes, great, what do I get for that? And you report new analysis. No, the report that ran yesterday will still run tomorrow. That's not a good business case. So just a quick poll here. Are you seeing any of these issues inside your organization? And please select all that apply. And they may call it different things inside your organization. So this data retention, we often hear customers talk about a retention window or limited data. So the numbers are still coming in, but it's pretty interesting. We're getting a lot of features across all of those different pieces. There's no clear winner, but clearly a lot of pain in certain areas, especially the ETL batch windows, the queries, the data field changes, and the growing costs. So a second major trend we're seeing is the importance of mainframes in this data insight. So don't forget the mainframe. Mainframes still are huge in all these organizations. So 71% of the top 500, the top 25 banks, insurers, retailers, etc. And when talking to these organizations, it's not unusual to hear that up to 80% of their corporate data originates in the mainframe. And that's serious big data. And organizations can't afford to neglect it. And in terms of the analysis, well, you can't do it on the mainframe. Mainframes already cost an average of $16 million a year to a top typical $10 billion organization. So you've got to bring it off to another platform to do that. And they're all looking at technologies like Hadoop and making mainframes a core part of their big data strategy. Because imagine the sort of insights you can get if you can take transactional data from mainframes on payments and transactions like retail distribution and combine it with clickstream data, web logs, and sentiment analysis. So this slide is not about managers and employees. It's not the suit and hoodie divide. It speaks to a fundamental difference we see between the traditional teams that deal with mainframes and warehouses and the new teams dealing with Hadoop. And yet at the same time, on the surface they appear different, they actually have much more in common than they realize. So on the integration gaps, on the mainframe they have this data format called EBCDIC and packed decimal. It's because storage was so precious up there that every byte mattered. But what it meant was that up on the mainframe, it's really difficult to take that data and bring it down and understand it. You can't open it in a text editor and just read it. And the really funny thing is that EBCDIC and packed decimals were actually positioned as security standards originally because it's so difficult to figure out. On the expertise side, I'm sure everyone's heard about the crisis we seem to think we have with data scientists, but on the mainframe they have a similar problem. A lot of the resources are close to retirement, so there's a skills gap there as well. On the technology side, if you take a mainframe developer and give them Pig, one of the languages inside Hadoop, they'll actually pick it up really well. It's a language they can relate to. They'll struggle going from ZOS to Linux. And also the security thing, it's huge. The mainframes have all this mission-critical data, so bringing that into the new environment, you've got to find an easy way of transitioning it across. And there's so much potential. The cost savings you can bring, not just from data, but also workload off the mainframe to these other systems, really offers great advantage. And like I said, these groups, they think they're really different, but they're really not. I mean, they have to work together for this to be successful. So bridging the gap to deliver that insight, they're looking for this strategy to bring it all together, and an enterprise data hub that Matt will now cover will make that work.
Thanks, Steve. So, as you mentioned, we're in the middle of a shift in how businesses use information. In the past, you define a set of business processes, a set of reports, and BI requirements, build applications around each one of those, and then go about gathering, conforming, and merging the necessary data sets to support those applications. From an infrastructure IT perspective, you'd be bringing the data over to the compute, often in relational databases, but you'd be leaving quite a lot on the table and at considerable effort. The modern realities of business demand a new approach to augment the existing, where today companies need more than ever to become information-driven. But given the amount and diversity of information available and the rate of change in business requirements, it's simply unsustainable to keep moving around and transforming huge volumes of data. You want to start thinking about how you can bring the compute to the data. Now, the foundational platform that's helping address this wide range of problems today is Apache Hadoop, which many people have heard about, not a lot of people really understand, and there's a lot of hype, to be honest, and this is coming from the vendor, right? There's a lot of hype around Hadoop today. Hadoop is, just by definition, an open source platform for scalable, fault-tolerant data storage and processing that runs on a cluster of industry standard servers, just typical hardware. But it turns out that Hadoop, even just a few years ago, wasn't capable of solving the problems that Steve laid out. You could bring workloads like data processing to an effectively limitless amount and variety of data provided. One, you employed highly skilled computer scientists to operate your cluster. Two, the only kind of work you wanted to do was batch processing by writing Java code. Or three, you didn't need your data to be comprehensively secured. Now, obviously, these all need to be addressed. So Cloudera solved the first problem with Cloudera Manager, which is the leading system management app for Apache Hadoop. Cloudera Manager is very popular with customers because it makes the complex simple. Hadoop is more than a dozen services running across many machines with limitless configuration permutations. With Manager, customers can centrally manage and monitor their clusters, tens, hundreds, thousands of nodes, from a single pane of glass in a single tool. It provides automated installation and configuration of your cluster. It's really our many years of Hadoop experience realized in software to help you get up and running quickly. So there's management. Now, this is where it gets interesting and exciting. So let's talk about that second problem, moving beyond Hadoop's batch-only roots. So our customers liked the scalability, flexibility, and economic properties of the platform, but for example, they didn't like that they had to move data out to other MPP analytic databases just to run fast SQL queries to run BI. So we built a project called Impala, which is the world's first open source MPP analytic SQL query engine expressly designed for Hadoop. It's basically like a database in Hadoop. So in Impala, you now have a viable open source alternative to proprietary MPP analytic databases for exploratory self-service BI, one that also delivers the core scalability, flexibility, and economic benefits of Hadoop. For example, Tableau, which you'll see later on, has partnered with Cloudera to enable interactive BI queries on terabytes to petabytes of raw data, unconformed, untransformed, directly in Hadoop through Impala. Over the past year, we've continued to add to the platform with enterprise search, with a new project called Apache Spark that enables interactive, iterative analytics, machine learning, and stream processing in Hadoop. You also get something called HBase, which is the online key value store for building real-time online applications. The platform includes workload management through Hadoop Yarn and Cloudera Manager, so all these engines running on top of your shared data can peacefully coexist in the same environment. It really is a Swiss Army knife, if you want to think about it that way. It can do many things with shared data. Now, with this range of diverse ways to access your data in Hadoop far beyond just Java and MapReduce, you can now bring your existing tools and skill sets to the platform. So we talked about Tableau sitting on top of Impala, but what's even more exciting now is that we've recently made it possible for our partners, such as SyncSort and other third parties, to deploy, manage, and monitor their apps in the platform. So SyncSort sitting natively inside Hadoop, running directly on the data in place, leveraging existing investments and existing skill sets while letting you access an even greater breadth and depth of data all in one place. Now, of course, none of this would matter if the platform weren't reliable, secure, and manageable. Historically, early Hadoop developers didn't prioritize data security, as the use of Hadoop during this time was limited to small internal audiences and designed for workloads and data sets that weren't deemed overly sensitive or subject to regulation. But once you begin unifying data silos, incorporating new data types, and moving to production, these capabilities become mandatory very quickly. We see a lot of customers stumble when they get towards production and haven't gone through the security audit yet, and they get their projects blocked. So that's very important to look for up front. Now, Hadoop today is highly available. Cloudera provides extensions for automated backup and disaster recovery. Hadoop's had perimeter security for some time with Kerberos, but there was once a significant gap in the area of fine-grained role-based access controls, the kind of which you'd find in a database. That's why, together with the open source community, we built and contributed something called Apache Sentry, which gives you fine-grained row and column-based access controls for Hadoop data. And we also developed something called Cloudera Navigator to support metadata management, things like rights auditing, data lineage, where did data come from, where's it gone to, and data discovery, what data have I got, native to Hadoop. And all of this in addition to the system management and customer support that you'll need to be successful in production. Now, ultimately, you can see a lot's happened in just a few short years. What you have here at the end is what we're calling an enterprise data hub, which is one place to gather any amount or variety of data in its original form together securely, and to bring a variety of workloads, batch processing, analytic SQL, search, machine learning, stream processing, third parties, to the data in Hadoop without need to move it elsewhere. So with an enterprise data hub, our customers are able to store and drive real insights from more data than they'd ever thought possible by consolidating their environments. And beyond just the technology, Cloudera provides everything you need to be successful with Hadoop in the enterprise, including training, professional services, the backing of the industry's only predictive and proactive global support team focused on Hadoop, and along with a partnership with the experts who actually build Hadoop. So where do you begin? Where do you get started with all of this? We'll learn more about it in a few minutes, but an enterprise data hub offers the flexibility to start small while thinking big. Many organizations start by using an EDH for storage or active archiving, getting all the raw data in one place where you automatically have a compliance archive, if, for example, you're in financial services or healthcare where that matters. Or they'll accelerate ETL or ELT by offloading that processing from their data warehouse or mainframe environments to improve performance and save cost, while also enabling more data to be seen through interactive BI experiences that don't fit into, or new kinds of data that don't fit well into relational systems. Now, the best part of an EDH is, regardless of where you're starting, the flexibility of the platform to do multiple things with the same data allows you to evolve it over time and move from one use case to another as you transform your data management infrastructure to enable your enterprise to become information-driven. So where are you on your journey with Hadoop? Here's another quick poll as to how you're working with Hadoop. All right, seeing a lot of good results here. Seeing a lot of new people to Hadoop, so that's great to see. That really is very common at this stage. There have been a lot of early adopters of the technology, but now we're starting to see more mainstream enterprises begin to realize that Hadoop isn't just for data scientists for solving machine learning and analytic problems. It actually can be used to solve these fundamental IT challenges that have existed for decades. So let me hand it back over to Steve.
Thanks, Matt. So with the invention of Hadoop and an enterprise data hub, there's a new way of thinking. And this is the before. This is the traditional BI architecture that most companies still have today. You've got all these different data sources coming into a staging area that's sort of encroaching now into your data warehouse because it's doing ELT inside the main warehouse itself. You're trying to deliver out reports through traditional business intelligence tools. You've got a whole bunch of users that are frustrated because it takes 8 weeks to add a column through all these sources. They can't get the new sources they're really interested in. And there's really just a huge amount of frustration here. And this staging area is really important. Staging is, no matter which architecture you look at, Kimball, Inman, etc., they all have this staging area. And staging is the dirty secret that every company has to deal with. And because staging has migrated into the warehouse itself, you've got ELT. In some companies, it's up to 80% of their database capacity is doing the transformation. They've got all that dormant data that's just sitting there, not being reported on, but all the processes to load it and store it are going on. And it's just wasting cycles. And the end result is you've got slow response times for your users. Your warehouse administrators know exactly how much ELT is being done. We were at a customer a few weeks ago, and they were like, it's 44%. It's exactly 44%. So they know how big a pain it is. And it means that only the freshest data is stored online. So that historical data, anything older than 3 months in some cases, has to be stored outside the warehouse. And the really frustrating thing is that the scientists, the guys who you want to go and explore this data, they can't because the warehouse is so consumed with just delivering these standard reports. So today, it's not okay to wait weeks for insight. This is not a nice to have. This is a competitive requirement. And so you're seeing this new architecture. You're seeing the data sources feed into the staging area migrated to an enterprise data hub. They're doing ETL on Hadoop, but they don't call it ETL. They call it collecting, processing, and distributing data. They deliver that out to their existing channel, the warehouse, which is never going to go away. And what you're finding is because you're reducing the ELT workload, you're freeing up capacity. So suddenly you can do that more interesting analysis in the warehouse. But you could also point a discovery and analytics tool directly at the hub. And the real winner out of all of this, apart from the IT guys who get to maintain a much simpler and more flexible infrastructure, it's the end users. And that data hub serves a number of roles. So it becomes this active archive. It provides one place for all data types, cost effectively, full fidelity for any period of time. Second, it's a single location to transform data from its raw format into structured formats for consumption. Nothing is lost. And then third, those business users get direct, agile access to specific data sets to explore and analyze. And the real benefit comes from the fact you could increasingly bring new analytic workloads to an enterprise data hub. So, they've got native engines, batch streaming, interactive SQL, search, machine learning, and more. And you've got products like SyncSort that can run in the enterprise data hub natively and allow you to deliver out much better analytics to your end users and tools like Tableau. And this more data, varied data approach delivers a completely different way of analyzing the information. So you're probably sat there thinking, this sounds great. Where do I start? There are all these things that I might want to do. How do I deliver this environment? How do I optimize it? How do I bring in my mainframe data? So the great thing about all this is that because this is a well-proven process, there's a simple workflow to doing this. There's a framework for going about this. Step one is identifying. You're going to pick the data and workloads suitable for offload into an enterprise data hub. You're going to focus on the ones that are going to give you the most savings and most performance in phase one. So for example, we have a whole bunch of tools that will help you figure out what data is good to move across, and if it's going to move across, is it ELT, should it move? Phase two is the offload. You want to move all of that data, mainframe data for example, using one tool into that hub and transform it on the way in if necessary, but largely move it straight through. And take that staging that seeps into your data warehouse, your relational database, and move it back to where it belongs. And then finally, this optimize and secure phase, by being able to deploy this either on-premise or in the cloud, means that you can deliver this very quickly and immediately get value. And then ultimately, it's all about self-service reporting. It's all about giving end users access to the data. And now you have all that data in Enterprise Data Hub, you can use an amazing tool like Tableau to transform that organization with big data insights. And Paul, do you want to take it away?
Yeah, I do. Thanks, Steve. Tableau's had this mission statement since our inception 10 years ago, and that's to help people see and understand their data. And as we walk through the presentation today, both Steve and Matt have pointed out all the challenges of getting information and getting to it. And Tableau's approached this in a way that we feel is unmatched. It's the ease of use, the ability for any analyst to investigate, explore, and discover new insights. To do things like determine, what are good data points and what are outliers that I need to investigate further and deeper, and what are the things that I need to ignore that are irrelevant to it that maybe get in the way of me discovering the right insight. So as we've evolved on this mission, there's a number of things that will reinforce the points you've heard today. There's been a problem in organizations, and every customer faces this challenge. The volume of data, just the pure mass of it, is expanding everywhere. And the need of people to get to this and to do something with it is growing. So not just the IT or the business technology professional or the data scientist, but the person in accounting, the person in finance, the person in marketing, the person that just, has to get their job done, that is fighting to get to this volume. And to compound this a little bit further, it's not just the nature of getting to this volume of data. The data became more diverse, whether it's machine-generated data, unstructured data, text documents, very structured data, warehouse data. Business users and people that need it to make decisions have to think about this diversity of information that's out there, coming from all these sources. And in many cases, these sources, as was pointed out by Steve early on, are not accessible or even translatable easily for the business user. So going to the mainframe that books your transactions, very difficult to do. but getting to that information to make a better decision, critical need. So the challenges that we see in software is there's an old school problem, right? What most technologies have done since the beginning of time is they've served the few. They've relied on an army of engineers and this kind of high priest role that we like to talk about at Tableau. And there was a technical barrier to entry in order to do your job. You need someone else to build your report so you can make a decision, which seems like a crazy thing to think about, right? I have to wait or ask a question. I have to explain my business challenge to you so you can build a report to meet my need. And so what happened is the many started to evolve, right? And what business users started to do was to pull all the information out of all of these assets all over organizations to try to do their job. And they didn't do this to try to break governance or to try to break what IT was doing. They did it because they had a business problem that they needed to solve. And so they try with Excel to pivot huge volumes of data and combine sources from all over the place. And at the end of all of this, the analyst in general, the every person in an organization, this was too hard for them. They weren't able to do it. So in Tableau, we like to talk about the Tableau revolution. And, the revolution is really more about the fact that we don't believe that you need a team of engineers, the high priest role, the highly specialized analyst, or stale reports that look backward that don't help you make forward-looking decisions to prevent problems before they occur, as an example. We think that any user, any person that can use a mouse and use a browser and knows a little bit about their data can actually discover great insights and help organizations move forward. And we're going to show you a demonstration a little bit later here, and hopefully we'll make this point very directly. Key in all of this is the flexibility that's needed, right? How do you transform the data, whether it's a text document, a very structured ERP system, a data warehouse? And how do you take this flexibly to not just self-serve, but to empower people to do their jobs in a very different way? And at Tableau, we really talk about this flexibility as a fundamental part. Key in that flexibility, though, are the discovery platforms that allow people to go fish and find and discover new things in their business. Hadoop plays a tremendous role in the ability to do this and does it at a much better cost than technologies previously could. The ability to take that data from all the systems like SyncSort does is also key in providing the flexibility so the business user can focus on the business problem and not the problem of trying to prepare the data to do the job they need to do. And I would argue that most people in organizations spend 80% of their time preparing to do the job they need to do instead of doing it. And this flexibility helps, fight that challenge that organizations face. And the key thing for Tableau is this is for everyone, right? All departments, all use cases, users of all skill levels, whether you're an IT professional, whether you're a data scientist, whether you're the CMO, or whether you're just a financial analyst that wants to get some stuff done. These use cases can be supported, and you can do this. So we've got another poll question here, and I'd love to know what you guys think about, what are your biggest challenges with your current reporting and BI solutions? And if you take a minute to fill this out, we'll talk a little bit about the results, and then we'll get to a live demo. So we have a pretty cool mix coming in. Many of you can't combine multiple data sources, and there's a beautiful way to do it. That seems to be the slight leader at this point. But also data access, and it's hard to change and too slow is right there. And the dependency on the specialist that we talked about is kind of in third place. So I'm going to show the results here, and then we'll move on to a live demo. So I'm going to turn this over to Nikhil from SyncSort, and he's going to start with the problem of organizing the information to get to the analytics, and then we'll come back and we'll show you the business user view of that.
Thanks, Paul. So I'm going to start with showing you two jobs one of the jobs that I'm going to demo for you is more of a performance-related demonstration to showcase the speed and the resource utilization and efficiency of the DMX-H engine. I'm going to do that using 100 million records and aggregate it down and group it by a certain field in the data and output the aggregated data to approximately 2 million records. So I'm going to run this, believe it or not, as we do the other pieces of the demonstration in the background on my laptop, which has a few cores. So I'm going to hit the run button, and I'm going to run it on my computer, which is a laptop. And while that's running and crunching through the 100 million records, I'll just quickly tell you what it's going to also do is load all of those 2 million records that come out of the aggregation directly into Tableau using the Tableau native format, which is the TDE, or Tableau Data Extract, after the aggregation is done. So let's minimize this. We'll revisit this once we're done with the second portion of the demo. What I'm going to do now is connect to the second piece, which is the functional demo, to show you all of the cool things that we've been talking about. And I'm going to just quickly take a minute to connect to my virtual environment, which is a couple of VMs that I also have running on my laptop. So my laptop, while it's doing the 100 million record job in the background, has got 2 VMs open, PowerPoint, and a bunch of other applications. So one of the things that I wanted to show you today is depicted in this flow. And the flow is starting from the left. It receives daily retail transactional data from the mainframe, and that data is typically something that needs to be joined and looked up against a dimension table or a few dimension tables. Typically, this is done using a staging table and writing SQL in the EDW or the Enterprise Data Warehouse. What we're seeing in the trend that we're seeing there is to take some of that expensive staging and expensive CPU cycles and offload those kinds of ETL, ELT pushdown jobs to Hadoop. And that's where DMX-H can help. And so what this demonstration will show you is it will take the mainframe data, which can be pretty complex, sometimes very complex, and it'll basically make this process of ingesting that mainframe data very seamless to HDFS. So that's step number one. And that's the piece where you see SyncSource DMX-H connecting to the mainframe and to HDFS in one single step. We will also take the required table that we want to join with. In this case, it's a dimension table from the Enterprise Data Warehouse, and load that into HDFS. Once we've done that, we have the required data sets to perform the ETL transformation, which in this case is a simple join for the purposes of the demo. And once we've done the join in DMX-H, which is running on Cloudera, which is the VM that I'm going to show you in a couple of minutes, it's going to then take the resulting process transactional data and load it directly back into the EDW, as well as directly into the Tableau format, which is the TDE. So what does this entire flow look like in DMX-H? I'll just quickly get out of slides share mode and open up the job in DMX-H. And I'll show you the flow, exactly what that entire slide looks like in DMX-H. So everything you saw on that slide is happening in one single job with 3 sub-jobs or steps. The first step is to load mainframe data and the tables required from the EDW to HDFS. The second step is to do actual MapReduce processing using DMX-H sitting on Cloudera. And the third step is to take the results of the ETL process from HDFS and load it directly into the EDW or into Tableau itself, or both. So let's drill into some of these pieces. I want to focus on the mainframe to HDFS. If I double-click on the first sub-job, it opens it up in a job editor, and it has 2 steps, what we call tasks. The first task is to take the mainframe data, which in this case is called retailtransactions.dat, and of course the second one is to take the EDW, or the table from, in this case, the product table, dimension table, and load it into HDFS. So let's take a look at what the first step looks like. So if I double-click on that task, you have the source data, which is coming in from the mainframe, and then you have the target, which is going to HDFS. Under the metadata, you see there is a reference to a COBOL copybook. And if you are familiar with mainframe data and metadata, COBOL copybooks are nothing but the metadata that describes the actual data that sits in a mainframe file. So here is my demo environment. I have two virtual machines. One is a Cloudera virtual machine with DMXH installed on it, and the second one is the actual EDW VM. So they're both talking to each other as far as communicating, loading data back and forth. And if I log into this virtual machine, I have the COBOL copybook that I'm going to use, and it has various computational fields, what they call binary fields. Comp3 is packed decimal, if you've heard of that before. Comp is just a binary integer. You've got a bunch of character fields. So this is a medium complexity copybook. I'm linking to this copybook in my job, in my task, and then using that to map to the source file. So if I look at the actual source file and in the dropdown, I have the ability to connect to various formats, including a mainframe and mainframe vsam, mainframe variable. So what you can do here is a couple of things. You can actually use the COBOL copybook to sample your data, and you'll see that the sampling samples the first 100 records. So this data is actually data from the Tableau retail example. What we did was we took that data and blew it up into over 1 million rows for the purpose of the demo, and then converted it to a mainframe format so that we can start processing that data from the mainframe, bring it to HDFS, perform the ETL, and then load it into Tableau so that you can actually get the required big data insights at the end of the day. So you can see that it actually makes life a lot easier for the developer to develop mainframe sources because it actually gives you everything in readable format. If you actually tell DMX not to treat it as EBCDIC, you'll see very quickly what the data actually looks like on disk. So it's pretty much gibberish, right? So this is not something you have to deal with. You can just basically tell DMXH to treat it as EBCDIC, and it will, on the fly, convert that and sample it for you. On the target, you have a very simple way of taking data from the left, which is a mapping to data on the right, which is HDFS. Everything on the left is a mainframe. Everything on the right is HDFS. So it's very seamless to do this. So moving on to the second step, it's a very similar approach. The only difference is that I'm sourcing the data from the EDW to a product file on HDFS. So both of these files, transactions and product, are now sitting on HDFS. So if I go back to my main flow, the second step in the flow is to perform the actual MapReduce using the two files. So if I double-click on that step, you can see that is a very graphical way of developing your MapReduce jobs and run it on the Cloudera cluster or VM and so on. You can see there's a MapReduce link, and everything to the left is happening in the mapper, and it's all graphical, and that's the transformations. We're taking the two files and joining them, and the end result is being written back to HDFS after the MapReduce job is done. Once you're done with the MapReduce piece of it, the last step is to take the data from HDFS and load it back into the EDW or into the Tableau TDE format. So if I double-click on this task, you can see there's a Tableau connection, TDE native connection here, and there's also a connection to the Enterprise Data Warehouse. If I double-click on one of the targets, which is the TDE format, you can see that it's a very simple graphical way of taking data from HDFS and loading it directly into Tableau's native format, which is the TDE. So now that I'm done with the entire flow, you can actually look at the results of this job, which I ran recently, and it's very easy to actually look at the data and the tasks and what happened exactly in each step. So if we actually open up the entire flow and look at the various steps, you can see how much data was taken from the mainframe, how much data was taken from the EDW. You can look at the map-reduce jobs that were run, and then the final output that was written out. So that, in a nutshell, concludes the functional piece. Let's go back and revisit our job that has been running in the background. I will connect to my laptop and switch it from the virtual machine to do the actual physical laptop. And you'll see that the job is successfully completed. And if you look at the details, you'll see very quickly how much data was aggregated. So you've got about 64 million records being taken from one of the log formats. This is basically clickstream data, aggregated down to 1.2 million. And then you've got a lot, also about 35 million rows in the second step, aggregated down to a little less than a million. All of this is being written to Tableau's TDE format, and this whole job was done in 2 minutes and 34 seconds on my laptop in the background. So that concludes my piece. What Paul is going to show you is the output of my functional demo. Actually wrote the transactional process data to a TDE format, and I gave Paul the TDE format, and he's going to show you how you can get more big data insight using Tableau once DMX is done processing. So over to you, Paul.
Great, thanks, Nikhil. So for everyone on the phone, I'm going to try to make up some time here so we can get to some questions. So I'm going to try to do a very quick demo here of Tableau. So at Tableau, we really have 3 products, or 2 products, and then they're configured in multiple forms. We have Tableau Desktop, which is the main authoring product, Tableau Server, which is the main consumption product, whether you want to do that on the web or mobile. And then we also configure that into Tableau Online, which is our cloud-hosted offering, which is a configuration of server and desktop, and Tableau Public, which is our free-to-the-world domain, which is basically Tableau Server and Desktop. But basically, if you've got public domain data and you want to view it and look at it, you can go to Tableau Public and you can see all these best-in-class visuals that people just generated on housing data or anything of interest to them. So I encourage you to check that out. But over here in the desktop, you'll see that I can connect to file-based sources. I can also connect live to any of these server-based sources. In this case, I'm actually going to connect to the Tableau server and look at the demo set that we were talking about. So now I'm sitting in Tableau's desktop. Over here on the left-hand side, we have our dimension pane, and these are kind of the dimensions that users might think about, the measures that we're going to look at. And then over here in the right-hand corner, we have our best-in-class visuals. And if you hover over any of these, we tell you what you need to do to bring them to life. But in order to just jump into this, if I was an analyst, what I would maybe do coming in is, maybe I'd organize my dimensions a little bit. So I could drag region to state, and I can create a hierarchy on the fly. This doesn't impact my back-end source, but it allows me to model my information for the purposes of analytics. And now I have a hierarchy that I can leverage. If I throw anything under the grid and I want to undo it, you can simply go back. We have the idea of kind of this infinite undo where if you make a mistake, just back up. We want to work like an analyst works. But in this case, if I wanted to take the hierarchy I just built, and I'll pick state, and I'll pick sales, and I'm going to represent that as a map of the U.S. where the darkness of the states denotes the sales and the geocodes of the geocodes. You'll note in our dimension pane, we have all these globes by geocoded fields as well as these calendars by timestamps. If I happen to like this, I'll just call it map. I'm going to duplicate this one, and I'm going to show you another kind of map where the size of the circle now is sales and the geocodes of the geocodes. But I'm going to use that hierarchy I just built, and I'm going to drill down, and I'm going to go down to the zip code level. And maybe I want to do something like color categorized by my customer segments, and I'll turn that into a pie chart. So now the size of the circle are my sales, and the slices are my segments. I'll just call this one zip. I'm going to create a couple more visuals for you, and then I'm going to show you how we can share this for others to consume. I'm going to take a date field, and we'll automatically turn date fields into hierarchies. So I'm going to just drop down the month. I'm going to pull the year and quarter off, and maybe I'll look at sales over time and I want to turn this into a filled line. And again, to be consistent, I will color categorize by segment. So I'm going to call this one time. I'm going to create 2 more visuals, and then I'll show you how to share them. The next one I'm going to create is a scatter plot, and really I'll take sales and profit. And what I want to do is I want to see some outliers in my business potentially. So I'll take these, and then I'll say, show me the marks, color categorize by segment. Maybe I'll shape categorize by product category. And if I wanted to see how my segments were trending over time, I can simply right-click and say, show me a trend line. So now very quickly I can see my outliers, I can see my customer segments, I can see by products, and I can see how they're trending over time. Just going to call this one scatter. I'm going to create one more visual, and the main reason I'll do this is great for unstructured data. So in version 8 of our product, we allowed customers to break from the Cartesian grid, so the XY axis. And this allows you to do some really cool visuals. I can do things like bubble clouds. I can turn this into a text cloud. I could turn this into a tree map where I say I really want to know my customers in this tree map. And maybe I want to color categorize them by profit. So very quickly, I can interact with this information. I can do things like look at the underlying detail of a particular customer and drill in on it. Again, the ease of doing this is a key thing you should take away here. I'm going to call this one tree. So if I wanted to share this with other people, what I would simply do is create a dashboard, and I'm going to very quickly give you a map. I'm going to create a second dashboard, and on this one, maybe I'm going to take zip code. The key with the dashboards is I can control the resolution, I can control the size, and I can totally manipulate the experience for people. So in this case, I'm not going to name them anything just for the sake of time, but I'm going to create a quick interaction between the 2 dashboards. I'll call this one drill to zip. And I'll go from dashboard 1 to dashboard 2. And I'll just say OK. And because I made a hierarchy before, I don't have to do anything else. Maybe if I forget to do something, I can add other pieces. But for example, I will just presume that this is good. So now I can hover over South Dakota, say drill to zip. I've just filtered my dashboard just to those zip codes. If I want to turn any object in the dashboard into a filter, I can simply say use it as a filter. And then I can drag my outliers and I can filter by those. I can also use the color legend as a vehicle to see all the common points that I want to see. But if I wanted to share this with someone, it's as simple as doing server, publish, logging into my server, which I'm already logged into, and I'm just going to say push these up. I'm not going to give them a name just for the sake of time, and I'll publish them. But I can control the names, I can give them titles, I can do all of those things that you would expect you can do. And now I can open it in the browser. And now other people can consume this information via a mobile device, web, or multiple formats and tools. So I can control the resolutions, I can do all of that. So the same ability you saw on my desktop is now in an HTML format. I can, for example, go look at Georgia or West Virginia. I'll pick one here, say drill to zip, and I can focus in on that area of the country, and I can do it in a browser-based form. So at this point, I'm going to stop and turn it back over to Steve to wrap up and get to questions. Thanks, guys.
Thanks, Paul. Appreciate that. So now you've seen the technology, you've seen it in a demo, and we wanted to quickly talk about a great example customer. So this is a financial services firm, and they've done pretty much everything that we described in the webinar. So the first thing is they'd always had this mainframe data source that they'd never really managed to bring in. They actually had a 74-page COBOL copybook that described it. They'd struggled for quite a few weeks trying to decode it. A couple of our guys went in, and in an hour they had the data decoded. The tool basically helps do that. We then loaded it straight into HDFS, which is what they wanted to do next, so an EDH. The other thing that was really interesting is they had a whole lot of workload in a very large, very expensive relational database, and it was ELT. So they had moved that ELT and tried running it as HiveQL. It was much cheaper inside Hadoop, but it obviously wasn't running quite as fast as their SLAs. So then we basically showed them how they can move that ELT into DMXH running on Hadoop, so running in the same place. And instead of taking 217 minutes, it took 9 minutes. But the thing the dev team were most excited about was the maintenance. So it was much easier to deploy and maintain. So the real benefit to the customer is they got that mainframe data in, they put it into an EDH, which became their new staging area. They still had their existing warehouse with more capacity, and they could deliver it out to Tableau. So a great example. And so all through this presentation, we kind of, we're showing you a completely different way of thinking. And Cloudera, Tableau, and SyncSort together can really enable you to break down those barriers to big data insights. And it's using an approach that's already proven. It's in production environments with customers today. But I want you to consider these 3 quotes. I have these on my whiteboard in my office. The first guy you might have heard of, the second guy you might have heard of, third guy maybe not. So about 6 months ago, I was on a conference call, and Rusty, in a very nice American accent, which I will not try and impersonate, said, "Our data warehouse is like a barge ship, and it just can't be turned around." He's actually a VP at a Regions Bank. And I wrote this down on my whiteboard to kind of ground me. So what he's saying is that warehouses are great for a specific purpose, but they're not agile. They serve a great source of data through the organization, delivering very specific reports. But people are wanting more, different, faster. And that goes back to Henry Ford's quote. It's attributed to him. And he basically said, if I asked people what they wanted, they would have said faster horses. A faster, bigger data warehouse is not the solution. They're already faster. They're already bigger. They've been doing that for 20 years. You have to think differently, and that's Einstein's quote. If you try and use the same thinking we've already used, we're not going to solve the problem. And I think it's very important to note, we're not saying the warehouse is going away. We're saying the warehouse could be used more effectively if you take advantage of the stuff downstream of it, moving that staging area into an enterprise data hub that brings all the value. So on that note, just one final poll. If you could please click. We're really interested. We've covered a lot of topics in this webinar. So which ones really resonated with you? Which ones do you see inside your organization? And I'll give it 20 more seconds, and then we'll show you the results, and then we're going to go through the Q&A session. Okay, so a lot of people are interested in learning about Hadoop. It seems the top one so far is self-service. That offloading, staging, and ELT, we're seeing a lot of customers just, very interested in doing that. The cost savings and, more importantly, time savings really have an impact. So, Arlene, do you want to take over? And we'll go through the Q&A piece.
Sure, that sounds great. Actually, we wanted to close that poll, but I wanted to thank Steve and Paul and Matt for their wonderful presentations. It's so much information, and I noticed that we have some questions there. What I'd like to do is just remind all of you that you can submit a question on the left-hand side. We'll try and email out answers if we're not able to get to them, since we know that we're at the top of the hour. This webinar will be available on demand. Please visit Cloudera.com. Slides will also be available. Please feel free to contact our presenters directly. Paul and Steve, their emails are there, and Matt and Steve have their Twitter handles there, so please feel free to contact them. On the right-hand side here, we've identified some ways that you can download and test drive SyncSort on Cloudera, connect Tableau on Cloudera, download Tableau and play directly there in Tableau software. And you can also download CDH for free and try that out as open source. So many options for you to go and try out all of the products that were here mentioned today. So we do have some of the questions that are available. And I think one of the first ones, maybe Matt, you can take this. Questions about building a Hadoop platform with reporting and visualization layer on top of them. How do you do that? Would you skip a data warehouse option, or how would you do that as a complement with a Hadoop platform? Maybe you can take that question.
Well, sure. So it's a complex question. High level, we see customers do both kinds of things. We should discuss your requirements, but typically customers use BI tools like Tableau on top of Cloudera for faster exploratory or self-service BI, in particular for new kinds of data like log files that wouldn't be well suited for an RDBMS. But for operational or financial batch reporting, these are traditional BI and data warehousing, you may find a traditional EDW more appropriate. The agility of Tableau combined with the agility of Cloudera is really better for new kinds of data, new kinds of analytics as well. Typically, as Steve pointed out, we see both used in tandem, especially if there's an existing EDW environment where Cloudera can help offload some workloads and data from the warehouse or mainframe environments to reduce TCO while increasing performance and visibility.
Thanks so much, Matt. And I know there were a couple of questions about Tableau, and so Paul, maybe you can answer these. Is it possible to upload data directly to Tableau Cloud? And does Tableau allow for real-time analytics on large volumes of data?
Yes. So the answer to both of those is yes. Tableau's online product does use our TDE format, so you can push data there. You can also connect live cloud to cloud with Amazon, Google, and Salesforce as sources. In terms of our ability to get to large volume data, the main way that we built our technology before we had an extract engine was live sitting on top of databases. So we have live connects to all the major Hadoop players, Cloudera, Horton, and MapR. We also have NoSQL partners that we connect live to, and we connect live to all the big EDW databases as well, Teradata, Vertica, and all of those types of sources. So we can sit live on top of them and let you discover data where the data sits. And one of the big things that I would say about our presentation today is that discovery exercise is where I personally believe the value is, right? Getting more people capable of doing it is really a big thing. So Tableau's mission to help you see and understand data is realized by connecting to all of these sources and playing live on top of them and being able to mash up results and do other things and think like a business person thinks.
That sounds great. Just one last question. I think there was a question in there about how Hadoop can change the time being taken by ETL development. And I don't know, Steve, if you wanted to take that or in a combination with Matt, but talk a little bit about that function.
Yeah, no, we're definitely seeing that Hadoop, so the SyncSort engine can run on open systems, Unix, Linux, Windows, and run very well. We scale very well sort of vertically. What Hadoop and Cloudera's Enterprise Data Hub gives us is very good horizontal scalability. And the funny thing is, if you think about ETL development, it's not just building the logic, it's running the tests with the data volumes. And if everything is going faster, so your test cycles are shorter. So yeah, it can have a massive impact, very positive. And also you get much more flexibility because really you can throw much more data into that hub and then deal with it downstream as well.
That's great. And I know we're over time. There are more questions here, but we will try and get back to the ones that are here. I do want to point out that our downloads for Cloudera are simply cloudera.com/downloads, so it's very simple to get there and do that. And Paul, Matt, or Steve, any last comments you'd like to make to the group since we are over time?
Definitely, Arlene, appreciate everyone's time, and feel free to email and contact us with more detailed questions, and we will try to go through all of the questions in both the chat window and question pane here and make sure that we get responses to you. But do feel free to reach out if you would like to know more.
Yeah, absolutely. If there's another topic you would like in more detail, so if you want to know more about an Enterprise Data Hub or specific data sources, then please reach out to us. Thank you.
Great. And with that, I think we'll close the webinar for today. Thank you all for attending.